Da-da-da-da-da! Grab your pals and come with me to X-Ray land and you will see them bones, and me!
Hi, I'm Danielle, and today we're going to be talking about the X-ray circuit. Come on, follow me. This is a replica of an X-ray circuit. Ooh, ah. So first, what do we need to start this circuit?
Oh, I know. We need power.
That's right. We need electricity. Zap, 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 zap. Okay, so outside, when we have electricity going through houses, they're at 220 volts.
Gee whiz, that's a lot of voltage.
But when they come in, it's changed from the transformer to 110 volts.
We have power now. Can we turn it on?
Yes, Mr. Levi. So to turn on the power, we need to hit the main switch right here. And when you hit it, it starts having electricity start to flow. We have one line of electricity going this way, one line going this way, and a third line going this way.
While the X-ray is warming up,
This is when we would position our patient on the X-ray table. I'm going to roll you to your side, ma'am. Very good. Now hold still. I have to go set up the machine. And then once we do this, we can set our control panel. For example, let's say we want to set the KVP to 120. Beep, boop, boop, boop. Wow, 120. And maybe you want your MOS to be 25. Bork, 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 bork. Wow! So all our things are now set up and ready to do the exposure on our patient. After we set the KVP, this sends a signal to tell the kilovolt meter where to go. So see these dials here? The arrow will point to 120 because I set it for 120. And this is where our first induction happens. Very important.
What about the MOS?
I didn't forget about the MOS. Let's look down here. This is the ohm meter. And this is where the preset 25 we picked will go here. So it will go to the correct spot to pick 25, like I set it for. And this is where our second induction takes place. So you remember those 3 lines of electricity I mentioned at the beginning? Well, line number 3 has to go all the way to the area near the auto transformer. This is where induction number 3 occurs. But they don't touch, they can't connect.
Huh? Why can't they connect? I don't get it.
That's a great question. The reason they can't connect is because one side is for the kV and the other side is for the milliamperage. So we don't want to confuse the circuit and put them together. So we use induction, okay? Okay, so now that everything is set, we have our KVP, we have our MOS, and everything is ready. Next is time to take the exposure switch, like this. And then what you're supposed to do is hold down the button for about 3 seconds until it lights up and makes a sound. No less time. You have to wait for that beep, okay? Pippa, would you like to do a demonstration for me? Yeah! Great, stay there. Let's pretend that this button is the exposure switch. I need you to hold it down for about 3 seconds until you hear a sound and see a light. Can you do that?
Yeah.
Great, let's do it. Okay.
Yay, baby!
Good job. That was excellent. Let's go back to the drawing board. When Pippa hit the exposure switch for the 3 seconds. It works like a drawbridge, opening up and allowing electricity to move through it for 3 seconds. When the electricity passes the setup transformer, the voltage changes from 110 volts to 10,000 volts! Ah! That's so much voltage. So, to make sure things run smoothly, the voltage is gonna go like a droplet at a time.
Like a leaky faucet?
Yes, Sherlock. Like the leaky faucet dropping a little bit at a time so that the 10,000 volts doesn't ruin the circuit. Once 10,000 volts goes to the step-up transformer, it will be placed in the capacitor, where then, from there, it will move on to the falling load generator. It goes one droplet at a time so it doesn't overload with voltage. Do you get it, guys? Great. This area is also known as induction number 4. Okay, so see here, this is the MA meter. It has 2 jobs. One job is to measure the amount of mass. The second is to let those 10,000 volts come in.
Question. What if it's not 10,000 volts? What if it's more or less? Oh, what do we do?
Great question. So let's say it goes to the MA, right? And it's 15,000 volts, not 10,000. That's way too much. So that is going to get stored here in the ground. But let's say, for example, it's 3,000, a very small number. Then it has to stay on the low voltage side, going back and forth, because it cannot cross over. These drops of 10,000 volts go to the rectifier and will change it from AC to pulsating DC. This is called induction number 5. Now let's talk about the rectifier, which is over here. Now the electricity is going to go in 2 paths.
Levi Brown, Levi Brown, hi, she. Meow, 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 meow. Levi Brown, Levi Brown. I see mew mew. I love cats. I love cats. We're talking about Xray circuits, but I love cats. Meowsers, cats.
Okay, so now let's look at the X-ray tube. The 6th induction takes place at the stator because the rotor moves the magnets. Induction causes anode to spin Ma on the filament side, causing a thermiotic cloud to strike. It hits the anode and some bounce around, and the good ones become an X-ray photon. Okay. And there you have it. Any questions, friends? Sherlock, yes.
How is the beam kept straight?
Wow, what a great question. So the beam is kept straight because of the focusing cup. It's the focusing cup's job to keep the beam straight so it doesn't go up or down. Great question. Any others? Pippa, yes. What's your question?
What's the filament made of?
That's also a great question. The filament is made of tungsten wire.
But the tungsten wire, won't it melt?
Oh, that's a good question. But no, it won't melt because tungsten is actually picked because of its high melting point.
Oh, I see.
So it will not melt. Oh no, that's all the time we have. Well, come back and join us again as we discuss more X-ray fun. Bye!
Grab your pals and come with me to X-ray land, and you will see them bones and me.